Good morning, everyone. Today we are going to revise lines and angles, right? So the very first thing that comes into our mind when we read this chapter name, that is what are lines, right? So actually lines are nothing, just if we talk about the lines, right? If we draw a straight path, which is having both side arrows is known as a line, right? Suppose I name it as AB. So I can write down it as AB with a symbol over it, that is a line. That means AB is a line. So any straight path that extends endlessly on both the sides, and that particular path is known as a line. So a straight path that extends endlessly in both the directions is known as a line. Next, we come to the part of lines. So the very first part of line that we have is line segment. These are very basic terms that we use in geometry. So line segment is a part of line with two particular endpoints. If I'm taking two endpoints, I'm naming it as M and I'm naming it as N. And if I'm joining with a straight line, then it becomes a line segment. So how can I just denote line segment? Mn with both side endpoints, a line segment symbol. So we can just note down a line segment is a part of a line with two endpoints. Next, we come to array. Ray is also a part of a line, but one point is fixed here. So if I'm taking a one point as fixed and I'm taking never ending point on the other side, then it becomes a ray. Suppose I take it as T and this is this. So how we can write down it, the symbolism of ray is TS with an arrow over it, right? So T is a fixed point. So we need to remember that when we are writing the symbol for ray, the fixed point needs to come on the first place and then the never ending point. So T will come first and S will come at the second place. So TS is a ray here. So let's quickly note down about array. Array is a part of a line with one endpoint. Next, we come to the next term of the chapter's name, that is angles. So when two rays, when they are originating from this common endpoint, when they are originating from a common point, that is known as then an angle is formed, right? Suppose if I am taking this ray as OT, and another ray is also originating from this point. I name it as OS. So the angle is formed on the vertex O. So here in this case, TS, OT and OS are the arms of the angles. And O is the vertex of the. And the angle is formed on O. So whenever we need to write down the angle name, we always write down either with a 3-letter, we take up 3 letters, T, angle T, O, S, where the vertex comes in always in the middle. Or we can write down this name as angle S, O, T. O will always come in the middle. And if we are writing the angle name with a single letter, so we can write it down as angle O, just the vertex name. So you can write down an angle is formed when two rays, lines, or line segment originate from the same endpoint. So the rays making an angle are called the arms of the angle. And the end point is known as the vertex. Next, we come up to another term, that is complementary angles. So whenever we are having any two angles whose sum is 90°, so they are known as complementary angles. So two angles whose sum is 90° are called complementary angles. So if we need to take an example here, so suppose 50°, I am taking one angle is 50°, another is 40°, and if I am finding out their sum, that comes out to be 90°. So 50° and 40° are forming complementary angles. So we can say therefore 50° and 40° are complementary angles. Next we come to the supplementary angles. So whenever we are having two angles whose sum is 180 degrees are known as supplementary angles. So we can write down two angles whose sum is 180 degree are called supplementary angles. So for example, if I am taking two angles as 120 degree and 60 degree. So 120 degree and 60 degree sum is 180 degree. So therefore they are a pair of supplementary angles. So we can say that 120 degree and 60 degree angles are supplementary angles. Next we come to parallel lines and a transversal. So actually, what is a transversal first of all? Transversal is nothing, just a line that intersects two or more lines at different points. If suppose I am drawing two lines and a line is passing through it. Suppose this is M, this is N, and a L line is passing through M and N. So this particular line is meeting M and N at two distinct points. We name it as A and B, right? So this particular L line will be known as transversal. Okay, let's move forward. So when any transversal meets any two intersecting lines, when any transversal is meeting any two intersecting lines, suppose so 8 angles are formed on these two distinct points. You can check 1, 2, 3, 4, 5, 6, 7, and 8. These are the 8 angles that are forming here. A transversal forms 8 angles if it is joining any two lines. Now there we have different type of angles. One is corresponding angles. So if we talk about the corresponding angles, so angle 1 and angle 6 forms a pair of corresponding angles. Next, angle 4 and angle 7 forms a pair of corresponding angles. Angle 2, angle 5 forms a pair of corresponding angles. And angle 3 and angle 8 forms a pair of corresponding angles. Next, we have alternate interior angles. Now if we talk about alternate interior angles, so angle 4 and angle 5, one pair. And another pair is angle 3 and angle 6. These are alternate interior angles. And if we talk about alternate exterior angles, angle 1 and angle 8, and angle 2 and angle 7 will form alternate exterior angles. Now, another type of angles that are forming here are interior angles on the same side of transverse. So, interior angles on the same side of transversal are angle 3 and angle 5. Another one is angle 4 and angle 6. They are the interior angles which are lying on the same side of the transverse. Now, next we come to the transversal of parallel lines. Now, if we are having any two lines which are parallel to each other and a transversal is passing through them, L and M are parallel, N is a transversal line. Again, 8 angles are formed. 1, 2, 3, 4, 5, 6, 7, 8. But when a transversal is passing through a parallel line, then each pair of corresponding angles are equal. You can just note down. Each pair of corresponding angles are equal. Each pair of alternate interior angles are also equal. And interior angles on the same side of transversal are supplementary. So in this particular figure, if you see corresponding angles are equal, that means angle 1 will be equal to angle 5, angle 4 will be equal to angle 8, and angle 2 will be equal to angle 6, and angle 3 will be equal to angle 7. They are the pairs of corresponding angles. If we talk about the alternate interior angles in this particular case, so angle 4 will be equal to angle 6. Angle 4 and 6 are forming a pair of alternate interior angles. They are equal. And angle 5 and angle 3 is also a pair of alternate interior angles. They are equal. And if we talk about the interior angles on the same side of transversal, they're always supplementary. That means their sum is 180 degree. So angle 4 plus angle 5 is equal to 180 degree. And angle 3 plus angle 6 will equal to 180 degree. Now we have one type of angle which is known as the adjacent angles. So if we am having two angles, one angle is ABC and another I'm taken one more arm in between this angle, which is BD. So angle ABD and angle DBC, they are adjacent angles because they are sharing a common vertex. They are sharing a common vertex that is B, and both the angles are sharing a common arm as well, which is BD. And their non-common arms are lying on the either side of the common arm, right? That means AB and BC are lying on the opposite sides of BD. So you can just note down. Two angles are adjacent if they have a common vertex, a common arm, non-common arms lie on the different sides of the common. In this particular case, angle ABD and angle DBC are adjacent angles. Next, we come up to linear pair. The linear pair of angles are the adjacent angles whose sum is equal to 180 degree. If I have taken this as a straight line and I'm drawing a ray over it, be it OC. So angle AOC and angle BOC, they are formed on a straight line. That means their sum is 180 degree. They are a pair of they are a linear pair, right? Linear pair of angles are adjacent angles whose sum is equal to 180 degree. So we can say here angle AOC and angle BOC is a linear pair. Which actually means that the sum of AOC and angle BOC is 180 degree. Next, we come to the vertically opposite angles. Now, if we talk about the vertically opposite angles, the vertically opposite angles are always formed when we have two lines which are intersecting each other at a common point. Okay? If suppose I'm taking this as XY and I'm taking another line as PQ and they are meeting at a point which is O, so a cross is formed. So this particular cross, we can say that vertically opposite angles are formed here. So you can write down vertically opposite. So angle XOY, XOQ is equal to angle POY. They are a pair of vertically opposite angles. Angle XOP is equal to angle QOY. They are also a pair of vertically opposite angles. So we can just note down vertically opposite angles are formed when two straight lines intersect each other at a common point. The vertically opposite angles are equal also. The vertically opposite angles are equal. So here in this case, angle XOQ is equal to angle POY. And angle QOY is equal to angle XOP. So they are a pair of vertically opposite angles. Now, in the next class, we'll discuss the questions based on these particular concepts. Thank you so much. Have a very good day. Bye-bye.